Hi students, we'll continue with the chapter Chemical Reactions and Equations. Today we'll be discussing the topic types of reactions. In the types of chemical reactions, we have five different types of reactions are shown here. Out of that, four is represented as diagrammatically. Here, if you go for the combination reaction, number one is combination reaction, number two decomposition reaction, number three displacement reaction, number four double displacement, and oxidation and reduction reactions. These are the main five different types of reactions, chemical reactions. And the pictorial representation is shown here. A plus B is combination, this is decomposition, this is displacement, and whereas this is double displacement, whereas oxidation reduction reaction, all these are coming under the oxidation reduction reactions. So we'll discuss one by one. Actually, chemical reactions involve breaking and making of bonds, we know that. So first we'll discuss about the combination reaction. Okay, the first example shown in the text is adding water to quicklime. Quicklime means calcium oxide. To that we are adding water, hot water, and we are getting slaked lime, okay, along with the liberation of heat. Okay, so calcium oxide is combining or reacting with water to produce slaked lime, which is producing heat. So it's an exothermic reactions in which heat is being evolved is called a exothermic reaction. Okay, so here this is a combination, two elements combine to form a single compound, but here along with the reaction we are getting heat also. So this is a combination reaction. At the same time it is an exothermic reaction. So in the beaker, if you touch the outside surface of the beaker, after the reaction between quicklime and water, can see that it is showing temperature, high temperature. The heat we can feel using in our palm. Okay, so the first example for combination reaction, and it's showing the uses of slaked lime solution is used for whitewashing. See, the picture shows it is used for whitewashing. And why it is used for whitewashing? What is special about calcium hydroxide? Okay, what happens is when you are making a solution of calcium hydroxide, it becomes calcium hydroxide aqueous. So when we apply this paste on the walls, what happens is it is absorbing carbon dioxide from the atmosphere and reacting with carbon dioxide to produce calcium carbonate, okay, which is a shiny substance, so which gives a shiny finish to the walls after 2 or 3 days. So that is the reason why we are using calcium hydroxide as for whitewashing. Okay, calcium carbonate is being produced by absorbing carbon dioxide from the atmosphere. Okay, so when we are applying that mixture or slaked lime on the wall, it will be dull looking, but after some few days you can see that it is becoming shiny. Okay, calcium carbonate, we know it is marble, eggshell, all these things are having calcium carbonate in it. Another example for combination reaction, see here one more thing I want to tell you is burning of coal. Burning of coal or burning of any fuel can be considered a combination reaction. In all the burning process, what is happening is the fuel is combining with the oxygen, producing corresponding oxides. Okay, here burn coal, which means carbon, is combining with oxygen, producing carbon dioxide. So an example for a combination reaction. At the same time, burning we know produces heat. Okay, so it's also an exothermic reaction. Then burning of hydrogen. Another fuel it is burning of hydrogen. It combines with oxygen to produce water. Also there is liberation of heat. So this is also an exothermic reaction. So all that, so what we have understood is the combination reactions are exothermic as well. They releases heat energy during the reaction. Okay, so they are also called exothermic chemical reactions. Okay, we go for some more examples. Another fuel, methane or natural gas burning, we are getting the oxides of carbon as well as hydrogen. That means carbon dioxide and water with the liberation of heat and heat energy. That is why we are using this natural gas as a fuel in the kitchen and all. Okay. Then another interesting example is respiration. Respiration means combination of the glucose in our body. What is happening is the food we eat gets uh, decomposed into glucose, and the glucose in turn combines with the oxygen we are inhaling to produce carbon dioxide, water, and energy. The energy is what we are using for doing our work. Okay, so respiration. This is the equation. It shows a respiration as a combination reaction as well as it's an exothermic reaction. So why do we call respiration exothermic reaction? Because there is liberation of energy. Okay. Then another examples are decomposed vegetable matter into compost, burning of magnesium ribbon which we saw in the previous examples. These are examples for combination reactions. And one thing we noticed is in all the cases there is liberation of heat, or otherwise they are exothermic reactions. Okay, the next category is decomposition reaction. So decomposition is actually the opposite of combination reaction, in which a single reactant breaks down to give simpler products. Okay, so what we are taking is a single substance which in turn breaks down into simpler one or more products. Okay, so here what we are taking is ferrous sulfate crystals. Ferrous sulfate is a green colored solid which on heating, okay, produces ferric oxide, sulfur dioxide and sulfur trioxide. Two gases are being produced together with the formation of ferric oxide. So ferrous sulfate crystals is getting another color. It's a dull brown color is occurring after heating it. So what happens is the breaking off or the decomposition of ferrous sulfate, and the products are ferric oxide, sulfur dioxide and sulfur trioxide. So one thing you notice, we are supplying heat. That means in the reaction, or if we want to conduct the reaction, we need to supply heat. Such type of reaction in which heat is being absorbed, they are called endothermic reaction. So decomposition reaction with this, as well as it is an endothermic reaction. Then another example is decomposition of calcium carbonate. And this is how calcium oxide is produced. Calcium oxide we learned in the previous example, it is quicklime, which is used for whitewashing. That is produced by the decomposition of calcium carbonate or limestone. Okay. Again, heat is applied to calcium carbonate, decomposes to produce calcium oxide and carbon dioxide. Okay, so again it's a decomposition reaction and endothermic reaction. Another example, heating of lead nitrate. Heating means endothermic. So lead nitrate crystals, which is white in color, decomposes on heating to lead oxide, nitrogen dioxide and oxygen. See the test tube, it is showing a reddish brown colored gas is coming out, and that is due to the production of nitrogen dioxide gas. So nitrogen dioxide, keep in mind, it is a reddish brown gas. Okay, so the colorless or white colored crystals is turning lead oxide, which is yellowish in color, and reddish brown vapors are coming out. Okay, which is of nitrogen dioxide. Another decomposition reaction, another endothermic reaction. Okay, now one very important decomposition reaction is decomposition of water. So what I have to do here is we are taking water in a mug, which is inserted with the two test tubes, two electrodes. We are having a cathode and an anode. Okay, and we are adding a pinch of sulfuric acid into it in order to make it acidic, in order to make it conduct electricity. Okay, so we set up an arrangement like this in which we have anode, cathode, electrolyte, and a source of electricity, battery, 6-volt battery is taking. Okay, now after some time, if you switch on, you can see that there is production of gas on both the test tubes. See, the test tubes are being kept inverted, and we can see that the gases are getting collected over the test tube. And the one difference is, in one case, the gap or the gas collected is doubled as that of the other. So here, the gas collected at the cathode is hydrogen, and the gas collected at the anode is oxygen. Because we know hydrogen, H plus ions, positive ions, cations will be moving towards the cathode. So hydrogen will be liberated at the cathode, and we are getting double the amount of hydrogen as that of the oxygen. Why it is so? That can answer by writing this equation. That means this equation shows very clearly decomposition of one molecule of water gives you two atoms of hydrogen, there is only one atom of oxygen, which means we are getting double the amount of number of atoms of hydrogen in the decomposition of a single molecule of water. So naturally, the gas collected will be double the amount. That is one important thing to be noticed. Then what we have to keep in mind is hydrogen is collected at the cathode, whereas oxygen is collected at the anode. Okay, so this is another decomposition reaction. Here it is electrolysis, we can say, because here the decomposition is taking place by the help of electricity. Or what is happening here is breaking off, or olysis. Olysis means breaking off water using the help of electricity. So the term electrolysis. And electrolysis of water, the products are hydrogen gas and oxygen gas. Okay, so that is a very important reaction to be keep in mind. Then and there are some other examples of decomposition reaction. Silver chloride. Silver chloride, if you keep in a china dish and allow sunlight to fall on it, you can see that it is getting decomposed into silver and chlorine. That means we'll be getting silver colored substance here. We'll be getting here, chlorine gas will be escaping out. Thus is called a photolysis, you can say, because photons are being folded in. Photons breaks, or sunlight breaks the silver chloride molecule into silver and chlorine. So the olysis, or the breaking down, is taking place by the help of sunlight. Okay, so this is also an example for a decomposition reaction. Just like silver chloride, we have silver bromide also, which will be breaking down in the presence of sunlight to get silver and bromine. And these decomposition reactions of silver chloride and silver bromide are used in black and white photography in the previous years. Okay. Then the third type of reaction is displacement reaction. Displacement, the word itself gives somebody is getting displaced by somebody. Okay, so these are the reaction in which more reactive element displaces a less reactive element from its compound. If you take for example, here it is showing a copper sulfate solution in which we are keeping two iron nails. Okay, two iron nails and after some time you can see that the iron nail is getting coated with the reddish brown colored substance, which is nothing but copper. So what happens here is the copper from the copper sulfate solution is getting displaced by iron. The equation can be represented like this: iron Fe plus CuSO4 gives FeSO4 plus Cu. This reaction is color change is very noticeable. For example, copper sulfate, which is blue in color, changes to green color. This is the color is very clearly shown here in the picture. It was blue first. After the reaction, it is becoming green. The reason is it was copper sulfate in the beginning, which is blue in color, whereas after the reaction, the solution is turning ferrous sulfate solution, which is green in color. And what happens to iron nail? Iron nail, the part which is below the copper sulfate solution gets a brown coat, which is, what is that? The copper is getting displaced from the copper sulfate. Okay, that copper has no place to go, so it go and get deposited over the iron nail. That is the reason why the reddish brown color of the iron nail. This is a typical example for a displacement reaction. So from this reaction we can understand that iron displaces copper. So what does the definition says? Definition is more reactive metal displaces the less reactive metal. Here iron is more reactive than copper, so it can displace copper from the salt solution. Okay. Now another example is zinc and copper solution. Here also we can see that there is displacement reaction taking place. That means zinc is more reactive than copper. Lead plus Cu. Again displacement reaction, CuCl to copper sulfate solution, copper chloride solution. It is changing into lead chloride because lead is more reactive than copper. So how do we know that which is more reactive? For that, there is a reactivity series of metals in which it is showing the reactivity series in the decreasing order. The most reactive metal is shown above and the least reactive is shown at the bottom. The reactivity decreases as we go down. So potassium can displace all the other elements, whereas sodium can displace all the other elements except potassium. See, zinc and iron, zinc is more reactive, so zinc can displace iron, iron can displace lead, zinc can displace lead, like this. So more reactive can displace the less reactive metal from the salt solution. So this reactivity series helps us to identify which is more reactive and which is less reactive. Okay, so that is displacement reaction, single displacement. Now the fourth type is double displacement reaction. The name itself suggests it is mutual displacement, or it is in term we can say, in other words, it is an exchange of ions between the reactants. Okay, so what happens, the typical example given in your text is this sodium sulfate and barium chloride. Sodium sulfate is a colorless solution where barium chloride is another colorless solution, and if you mix two colorless solutions as shown in the picture, we are getting a white precipitate like this. Why precipitate? Because this barium sulfate formed as insoluble in water, so we call it insoluble substances as precipitate. Okay, so barium sulfate is the precipitate here. It is an example for a double displacement reaction or double decomposition reaction, we can say in a way. And the white precipitate because it is insoluble. Barium sulfate is insoluble in water. Okay, so this is also called a precipitation reaction. Why? Because there is a formation of precipitate. Okay, so double displacement reaction where there is exchange of ions taking place, and in some case we are getting, if there is a precipitate, this also can also be called a precipitation reaction. Okay, another example for a double displacement reaction, this is also a precipitation reaction where we are mixing lead nitrate, a colorless solution, potassium iodide, another colorless solution, and once you mix them, we are getting this yellow color, appearance of this yellow color due to the formation of the precipitate lead iodide. Lead iodide is solid. It is written solid here. That means it is insoluble in water. That forms as a precipitate. So this is also an example for a precipitation reaction or a double displacement reaction. Okay. Now the last category is oxidation and reduction reaction. So here the definition is given here. Oxidation is the gain of oxygen or loss of hydrogen. And natural reduction is the opposite of oxidation, where a gain of oxygen will be changing into loss of oxygen. Loss of hydrogen is changing into gain of hydrogen. Okay, so oxidation is gain of oxygen or loss of hydrogen. Only keep in mind. Oxidation you can keep in mind. Just the opposite is the reduction. Only that is required. The first example shown here is burning of magnesium ribbon in air. Okay. Second example shown here is copper, heating of copper. Heating of copper in a China dish. Copper, it is reddish brown color. On heating, it becomes red copper oxide. Okay, copper oxide, which is black in color. That is, the reaction is given here. Cu plus O2 gives Cu. Black copper oxide. That is. Okay, that is also. So copper is gaining oxygen. So oxidation reaction. It is an oxidation reaction. Another, see, there is another example. The copper oxide, if you pass copper oxide through copper oxide, if you pass hydrogen gas, okay, it regains its reddish brown color due to the formation of copper. What happens is the hydrogen takes the oxygen from copper oxide, forms water, and copper is liberated, or copper is getting separated. That means the reverse reaction is taking place. So here what happens is, see, this is showing the what happens to hydrogen. Hydrogen is becoming water. That means hydrogen got oxygen. Hydrogen gained oxygen. So oxidation reaction we can call it. So this is oxidation reaction. Whereas what happens to copper oxide? Copper oxide loses its oxygen. That means it is reduction reaction. So this is oxidation reaction, whereas this is reduction reaction. Okay. So oxidation, reduction. Who causes oxidation to hydrogen? Copper oxide. For copper oxide, we can call it the oxidizing agent. Okay. Copper oxide, what happens to copper oxide? It gets reduced. Who causes it? Hydrogen. So hydrogen is called the reducing agent. Whoever causes reduction, called the reducing agent. What causes oxidation? Causes the oxidizing agent. Here copper oxide is the oxidizing agent, whereas hydrogen is the reducing agent. Okay, this reaction is called a redox reaction. Why? Because in a redox reaction, both oxidation and reduction reaction take place simultaneously. Such reactions are called redox reaction or oxidation reduction reaction. In short, it is called a redox reaction. Okay. Almost all examples are all reactions are redox examples for redox reactions. See, few more examples are shown here. Zinc oxide plus carbon gives zinc and carbon monoxide. What happens to zinc oxide? Loses oxygen. Whereas what happens to carbon? Gains oxygen. So this is oxidation, whereas this is reduction. And here what happens? MnO2, manganese dioxide, reacts with 4HCl, hydrochloric acid to produce manganese chloride, chlorine gas and water. Manganese oxide loses its oxygen, so it is reduction reaction. Whereas HCl, what happens? It loses its hydrogen. Okay, loss of hydrogen is again oxidation. So this hydrogen chloride is oxidized to chlorine, whereas manganese dioxide is reduced to manganese chloride. Okay, so reduction and oxidation reaction taking place. Here keep in mind, here loss of hydrogen is oxidation, and here loss of oxygen is reduction. Okay, so now, the effects of oxidation reaction in everyday life. If you observe in and around our surroundings, you can see that these pictures, whatever is shown in the pictures, are very well known to us. See, in the first example, see where articles are getting blackened, and see that this statues becoming green in color. Copper coins are getting green color. Iron chains are becoming rusty color. Iron nails are getting rusty color. So these are some of the examples of or effects of oxidation reaction in everyday life. Okay, so rusting of iron, A green coating over copper articles, black particles on silver articles are examples of oxidation reactions. Okay, and then what happens here, it is to avoid oxidation, we can add antioxidants. For example, these chips manufacturers are adding antioxidants to foodstuffs contain fats and oils. For example, chips and chips packets are filled with antioxidants. Usually, we are using nitrogen gas, which prevents oxidation. That means they are against oxidation. That is why they are called antioxidants. Okay, so what happens when fats and oils are oxidized? They are becoming rancid. Yeah, the taste and smell is changing. So to avoid that, we are adding antioxidants. We call it antioxidant because it is acting against oxidation. Okay, and keeping food in airtight container. That means avoiding contact with oxygen. Then only oxidation will be taking place now. So flushing bags of chips with the gas such as nitrogen. These are examples, or these are some of the solutions to avoid oxidation or avoid rancidity. Okay, so in this chapter, we learned the types of reaction, 5 different types of reaction. Then redox reactions example, effects of oxidation reaction and rancidity. The questions, the examples or board questions we'll be discussing in the coming video. Thank you.